This video is from section 9.1, Inequalities and Applications and Interval Notation also. So our three objectives are learning how to solve inequalities, learning how to use interval notation, and doing some problem solving with inequalities. So an inequality is any sentence that contains some kind of unequal sign. It could be a greater than or a less than. It could be greater than or equal to it could be less than or greater than. It could be less than or equal to or greater than or equal to, or it could be not equal. Inequality just means that it's not necessarily equal. In these two instances, equal is okay, but it's not the only thing that's okay. So here are some examples of inequalities. 3x plus 2 equals 7. C is less than or equal to 7. 4x minus 6 is not equal to 3. So here's some vocabulary. Let me see if I can manage to get a highlighter pen so I can highlight these. Let's see what I got. Let's see how this works. Okay. So we have a solution is any value that makes the inequality true. So in other words, any value that was less than or equal to 7 would be a solution here. So there's going to be more than one solution for almost every inequality you have. And the set of all of those solutions is called the solution set. So those are two words that should be added to your vocabulary list or your vocabulary note cards. To solve an inequality, you have to find all of the values that make the inequality true. Okay, some more vocabulary just for fun. We're going to do a couple of rules about inequalities. The addition principle for inequalities. You can add any real number to both sides of the equation of the inequality and not change the inequality. You can add a positive number or a negative number. But that's what all this says. You can add any number C and the inequality is still going to hold. And that's also true when you have the equals in there. Okay? So you pretty much have free reign adding. You're not going to mess with your inequalities. Problem comes in when you multiply and divide. If you multiply by a positive number, your inequality stays the same. So if you multiply by positive 2, your inequality would stay the same. Remember, you have to do it to both sides. Anything you do to one side, you have to do to the other. But if you multiply through by a negative, or divide through by a negative also, it flips the inequality. So if you start out with less than, you multiply by a negative number, you have to change to greater than. And vice versa, when you start with greater than and multiply not by a negative, you have to change to less than. So let's look at this inequality. I want to start to talk about different kinds of notation, different ways to represent the solution set for an inequality. Here we have the inequality where x is greater than or equal to 1. And right here we have represented it graphically. The solid dot right here means that it includes equals. If it did not include equals, if it was just x greater than 1, it would be an open circle. There are two other ways that we can write these that we're going to talk about. One is called set builder notation. And set builder notation goes like this. You start out with the brackets and you put in your variable name. The set of all x is how that reads. Such that x is greater than or equal to 1. You can't write out the set. You can't even begin because it's of real numbers. And for every two real numbers, there's a number between them. So you can't begin to write it out and then do a dot, dot, dot. So we do it like this. And again, you read it. The set of all x such that x is greater than or equal to 1. And we can also do interval notation. For this one, because the 1 is included, we're going to do square brackets. If it were not included, you'd do round. And it goes from 1, including the 1, to infinity. And you never put a square bracket on infinity, because you can't really pin down infinity. Say this was x is less than 2, we would go negative infinity, comma, 2, and we'd also have a round bracket on the 2. Interval notation is typically the quickest and easiest way to write them down, and one of the quicker and easier ones to read. In most cases. Okay, we can use some graphical methods to solve something like this, where we have two equations, or two expressions of x that are set equal to one another. So we can do it algebraically or graphically. This one we'll do algebraically, the next one we'll look at graphically. Okay? So here, remember, you're fine as long as you're adding or subtracting, or you're multiplying or dividing by positive numbers. The only place you might get into trouble is dividing or multiplying by a negative number. So here, I'm going to move variables onto this side, and I'm going to move numbers onto this side. So I'll subtract x from both sides, and I will get 4x minus 2 is greater than 10. Add the 2 to both sides, and I'll get 4x is greater than 12. Divide everything by 4. That's a positive number, so I don't need to worry about it. And I get x is greater than 3. So So there are three ways that we can represent this. We can have our number line. Okay, grab a different color. We can have our number line where we have 0, 1, 2, 3. And we're going to, x is greater than 3, so we'll put an open circle at 3 because it doesn't include 3, and then we'll shade up. Okay? We could write it in set builder notation and say the set of all x such that x is greater than 3. Or we can use interval notation. We're going to use round brackets on the side of the 3 because the 3 is not included. We're going to go up to infinity. So those are the three ways that you can write your answer. And the last thing we're going to do is solve this one graphically. So the way that we're going to do that is we're actually going to draw both lines. And we're going to see where they intersect. Okay? So this blue line, let me get a blue color to label that so we can keep these straight. This blue line is negative 2x plus 7 y equals negative 2x plus 7. Okay? Let me get a good pink. That'll do. And this one is 4x plus 1 equals y. Okay, so what we do is we take each piece of it, each side of it, and we make it an equation. Y equals negative 2x plus 7, and y equals 4x plus 1. And we graph those two lines and see where they cross. They cross at 1, 5. So this 1 is our critical line. We need to know what happens on each side of that 1. So when x is greater than 1, get another fun color here. I'm not trying to confuse you with colors. I just need to make sure it's all clear. When x is greater than 1, so let's pick x equals 2, okay? Just pick that. And we'll see when x is greater than 2, in here, which of the lines is on top? This one. If x were negative 2, this line right here would be on top. We're talking this side. So if x is greater than or equal to 1, then 4x plus 1 is the line on top. And we do want that. We want that to be the bigger one because we want the other line to be smaller than that. So our solution set is this: x greater than or equal to 1. In other words, a set of all x such that x is greater than or equal to 1, or that shouldn't be round, that should be square because the 1 is included. So it should be 1, infinity. Okay? Some people really like a graphic method better because they're very, very visual learners and they see things well. Other people really prefer the algebraic method, but they both get at the same answer.